Okay, so you've all got SketchUp or SketchUp Studio emailed to you over the weekend. It didn't come from Julio or myself, it came from Trimble. So do look at your emails. Don't leave it to a week beforehand or you'll have to email Julio, who will then have to email me for me to then reissue it to you. It's only valid for like 3 weeks, then you have to log into it within that time. If you don't, it'll cause Julio and me some problems, so please do it soon. Log on, download the software, and you'll have it till you graduate. Right. Let's just go with it. I'm going to always recommend, or I normally always recommend, that's an oxymoron, when we're having a brand new file in SketchUp, I would always go with the plane view, but in millimeters. So I'll do that. Please come up. There we are. So it's a brand new page. And when you get this brand new page, I'm going to assume, does that just sit there? I think it just does sit there, yeah. If we assume that you've got some level of knowledge of how to use AutoCAD or something like any drawing package, that's a good place to start. But if you don't have that knowledge, we've got a whole suite of 18 videos that I've done. Each video is no more than 10 minutes long, and it takes you from total beginner up to quite a fairly advanced level of BIM, of using SketchUp for BIM. I'm also conscious that I see some Apple's computers out here. The people using Apple computers, the software's fine, but the commands are slightly different. And also, you'll really need a mouse to use any drawing package. If you've not got a mouse, you will need a mouse. Right? Okay, and I'm sure they're cheap, or you can find something somewhere. Right, first thing we're going to do, we're not just using SketchUp as a drawing package, we want to put dynamic data or smart data into it. So the first thing we're going to do is go up to the ribbon menu, go to Tools, and go to the toolbar, and then we're going to open up the dynamic components. There's many others as well, but that's what we're interested in today, and I'll dock it up at the top. Now, I'm going to create for you 3 simple mass elements, or just blocks, a cube, if you will, of timber, concrete and steel. I'll put just only one piece of data in there, and that will be the mean density. And that's the exact same principle. If you've worked out your global warming potential, which is CO2 equivalent, or your embodied energy, which is in kilojoules something, then you can do exactly what I'm going to do just now, put it straight into your model, or you can extract the volume, which I'm going to do today, and then start using Excel there if you want. So I'm just going to quickly go in and create a cube. Remember, it's in millimeters, so it's 1000 millimeters. Now I'm conscious that here, if I move my mouse down in the down direction, it's not locking on, but if I snap it, it might snap to the green or it may snap to the red. If I press the right arrow key, it will snap to the red axis. If I press the left arrow key, it will snap to the green axis. And if I press the up arrow key, that's the vertical axis. Well, I want the green axis, 1, 0, 0, 0. And I can now use the rectangle tool. I'll go corner to corner. Then there's the push and pull tool, push and pull. And I'll go up, 1, 0, 0, 0. And there's the simple cube, 1 meter by 1 meter. What I'll do is I'll select the entirety of the cube. For any of you AutoCAD users, you'll know that all you'll do is you'll click on one corner and drag to the opposite corner, then release. And you've selected the whole cube. Once I've done that, I'll press M for move, select on the object, I'll press the right arrow key. At this point I'll press Control and I'll keep the original cube there. And I'll move it to roughly there. And then I'll press X to enter. Then I've got 2 copies of the original. Nice and simple. Right. If I just select the first cube, the entirety of it, right click, and then say Make Component. And I'll give this a name. I'll call it Timber. Just generic timber, right? And then if I go up to this tool here, and then I'll hover over it and it says Component Attributes. I'll select that. And I now have a menu that comes up. Now, I'm going to put in some attributes in here. I'm only going to be a very quick demo today. So I'll put in there the length, X, Y, Z. I'll just select all 3 just now. Now I want one more attribute. We're all engineers, so I want density. I want the mean density. So that's row. Row, well I'll use the small p letter to represent row. So I'll put P-M-E-A-N. So that's row mean. And for timber, that's 400 kilograms per cube. Well, that's representing a British conifer, or British spruce, or C16 plus for us engineers. Sorry, architect. So that's fine. And we'll give it a colour now. And we'll go Window, Default Tray, Show. And I'll just give it a yellow colour just now. Perfect. Do a very similar thing. The next one, right click, make component, we'll call it concrete. I wasn't joking before. Do the exact same thing, put length X, Y, Z, P-M-E-A-N, and for concrete, we should all know this, it's 2400 kilograms per cube. That's the density. And then all we'll do is we will give that a grey colour. I'm not saying concrete's boring, but it is grey. The last one, steel. Right click. Oh, sorry. I'll undo that. Right click. Make component, and we'll call it steel. And I'm just putting steel generic down. I've not put the grade of steel in, but I'm going to give the density for the steel that I actually want. We'll be creating, or in this demonstration, I will be creating perhaps a universal beam. So I know the density of that. So, but you can put in there your actual steel grade if you want. Just don't call it steel, call it the actual grade. Same with timber, you call it C16 or C24. It all depends on the level of detail that you need out of your model. And row mean, and that's 7882. That's 7,882 kilograms per cube. And I'll give that a colour as well. Give it a nice blue colour. Cool. Shot that now. So at this point, I've done this in a video for you online, and at this point here I took the steel and I then made a universal beam. I made a 152 by 89 by 16 kilograms per linear meter universal beam, and I then made that into a little frame. So you can watch that in the video, but for just now, how about we take the concrete block and we make a concrete floor, concrete wall, and maybe a simple roof. And then we'll bring in the model that I'd done yesterday in the video that you can watch afterwards. We'll bring that in inside, and we'll make it into some sort of structure with an internal overhead crane system. I know you're not doing a building with an overhead crane, but that's what I've got for you. And it will be a good demonstration of how to output the material that's in your structure. And I've got about 18 examples of videos using timber, so you can watch one of those 8 or all of those 18 if you want. But we'll do concrete just now. I'm going to press move, so select the concrete, press M, oops sorry, not rotate, move it, and I'll press Control to keep the original where I want it. And the first thing I'm going to have to do is tell it to be unique. I'll tell it to be unique, so I'll right click and say make unique. And at this point, what shall we make? Shall we make a floor slab? How thick? Now I'm not a concrete specialist, so I believe these are 4th year, yeah? So in your concrete structures, how thick would your concrete floor be normally? 150? Right, that's an absolute minimum, yeah. Near 200 for, depends, and then you've got yeah. We'll go with that now. So let's call this a floor. So I've got a naming structure that I have to use. Now, how my format of my naming structure you don't need to copy me, but you need to have a naming structure that works. So we'll use my one for just now, and I'll explain it to you. In my entity info, I'm going to go into definition. I'll take out the word concrete. I don't know if you can see this too well. I'm sure you can. My first part of my 6-part code will be the project number 1301 underscore. That's my project number, let's just say. The next part of my code is it superstructure, substructure, what level is it? So it's 1. So that's superstructure in my code. And then I've got where about in the building is it? Is it ground floor, first floor, second floor? Where about? We'll say ground floor. And then we'll say what's the material? What does it be concrete? I'll just call it CON underscore. This part we can call it floor slab. And then you may have more than one floor slab in your structure, because you can't just pour masses of vast of concrete all in one pour, or you'll have cracking. So what we'll do is, we'll assume that it's just one pour just now, but be mindful that in real life you would have to break that up. So we'll call it underscore 001. Or you could have west, east, south, or a different name, but it has to be unique. So this code here has got to be a unique code. You cannot have 2 items the same code in there. I'm going to copy that text, Control C, and then go down to my tags. For us AutoCAD users or Autodesk users who used AutoCAD in the past, tags and layers is the same thing. So if I use the word tags, just think it means layer. Okay? Right. So go down to tags, I'll press a new tag, and I'll paste in the name of the object that I've had before. Then I'll go back up of the entity info, and I'll request that entity now lives in that tag or layer, so I know where it is. And that's important when we want to do callouts and to do all our construction drawings from the model. Right, move that to the side. How big a building should we do? Let's just do 5 meters by 7 meters, for example, just now. So if I just take the tape measure tool, go along and do 7 meters, and then go down this way 5 meters. And you said what, 150mm deep, you said. Perfect. Quite a shallow one. Then we'll go in, we've made it unique before, we'll go in and we'll just push and pull it. And we'll snap on to my construction line, rotate it round, and pull this one out to my other construction line. If you can't see it on the screen just now, you will be able to see it in the recording afterwards. And then do a similar thing, select that face, bring it out to that line. In all my years as a structural engineer, I've never built a concrete building with walls before. But for the sake of this demonstration, let's just make our walls out of concrete. That's not a thing we would do in the UK. That's not a thing we would do. But let's assume that we're going to do that, okay? So I could delete all my construction lines, get rid of those. Take the original object, never delete or use the original object, just always copy from it. Press move, press control, bring it over. We'll make it unique. We'll give it a name. Remember it's 1301, what was it? Ground floor for concrete, and it's going to be a wall, and we can go west. We'll just have 4 walls in this building, yeah? How thick would a concrete wall be for a single story building, anyone? What's the minimum? I've never done a concrete building before in my life. Anyone? Massive bomb shelter stuff. Yep. I used to live in Germany, and there was a building in Hamburg that they had built during the Cold War. There's several of them, and it costs too much money to dismantle them, because they're like this thick. One's a nightclub, the other one's a climbing studio, like for rock climbing. Fantastic. Right, so you say 200mm, so we're going for a bomb shelter. Sorry. We'll just do this. We'll do it very quickly. We're running out of time. And what I want to do is just puncture some windows and doors is all I actually want to do. I don't really care about how it stands up just now. I take it, are you doing structural calculations for this building you're doing? You are? Member design? Perfect. Let's just say the height is 3 meters for this one. I'll just turn my phone off. And all I can do now here is just copy and paste, move it around. So we'll make them all unique. And we'll name this one East. And we'll make a new tag for it. East. We'll go to this one, make a tag for that. West. West. And if you don't mind, because I'm conscious of we're running out of time very quickly, what I'll do is I'll assume that there's 4 walls on this, yeah? Let's just put some windows and doors in here just now. If I go into the object, so if I select the object, double click to go in to edit it, I can then just put some random openings in. probably quite big. Select the face, push and pull. Now you can learn more about creating shapes on YouTube. So we're not here to teach how to create shapes. You can do that yourself in your own time. We're a university after all, we're not taking you by the hand. And we'll do something different on this wall. Let's just do a big opening in this one. And just snap onto the back. Again, my other videos will show you how to do this in much more detail. Perfect. Now I want to get some data out of this now. So if I just save this before we go any further, we'll do save as. I'll save it on the pen drive. And we'll call it number 4. So the sort of thing you really want in your project is the volume of material and perhaps some dimensions or other data. When we put the density in, so let's just get the weights of these components out. So if I just select the entirety of the building, excluding my original library of components, I go up to File, and I go Generate Report. I can now say create a new template. We'll create a new template, and I'm going to ask you for, I've given you documentation from Excel, so if you want to use my Excel document, please use the outputs in the same order that I've got it, and if we have time I'll show you how to create that template or modify that Excel template afterwards. But first of all, we'll say from the current selection, so we're going to exclude the things that we've not selected. So only the thing that we've selected we want the output data from. We want the definition name to be ordered by, then we want entity name, and then we want the length X, Y and Z. I'll just pull them over. And now I want entity volume, and then I'm going to want the row mean, the mean density of the material, and then just in case I've made a mistake and I've not named all my elements properly and I've copied and used the same thing twice, what I'm going to do is I'm going to have quantity as well. Let's find quantity. There it is. I'll press run, and it's output the name, the material, and some data about that. So if I just press download, and I'll ask it to put it onto the pen drive, and I'll do a new folder. Yeah. So I'll say yes, I want to open it. And this is just the raw data coming out. Well, before we go any further, Julio, we both mentioned this template, so we'll load that up just now. Yes? I hope so. Do I? No, I don't. Shocking. Let's find it. There's the one that I want. So this is our template. what I'll do is, I'll just select the entirety of the spreadsheet that came out of the BIM model, press Ctrl C, go into here, and on the first page, I'll go up to A1 and press Ctrl V. There's also instructions for you down here. And then to remove the units, because it outputs the units, you see, all I'll do is I'll just press the run macro. And my units have now been removed. I'll go to the next page, and I've now got a very simple output. I've got the name of the panel, I've got the material, and I've got the volume, and I've got the mass, or how heavy it is. Nice and simple. So if I come out of that just now, and I'll just delete that to start with, and if I go into a model that I'd done yesterday for the video, I'll copy that and I'll paste it into the one we've just done. Oh, I should save that. Helpful if I do save it. It would have been better if I'd remembered my sizes, but I didn't. Just imagine this is part of our structure in the next lab or the next room next door or something. This is what we create. Yeah, our steel structure, yeah. And I'll show you in the video how to create all of this. It's all the same section size. You could obviously create multiple section sizes for your design using the same material. So if I just grab the entirety of that, press File, Generate Report, press Run, and then press Download, and give it a unique name. Open it now. Select the entirety of the model, press Ctrl C, go in here, Ctrl V. Yeah, that's a template document which will give you. And we can press Remove Units. Now you could remove it manually, there's different ways to remove these units. We've just made a macro to do it for you. And if you want to make that different or change it, it's quite easy. And I can perhaps, if we've got time, we might not, we'll see. I'll show you how to do that afterwards. Go in here, and we now have not just my concrete that we had before, but all my steel elements as well. And it's giving me the material, the volume, and the mass. Now from that volume, the very minimum that you could do for your coursework is go into here and say the GWP, which is essentially embodied carbon, another word for the same thing. And you might have the GWP for concrete and steel and timber that you're going to have to research yourself online or somewhere. Have a look at some papers that people have written. Yeah, easy to find. And then you might want your EE value, embodied energy. So if you know that and you want to just do it all in Excel, easy. Or you could put it into the BIM model as I was showing you with the density if you want. So that is just one example of how to create a very, very, very simple BIM object with some data in there. When you start to do other, with the industry it's different. So I think at this point, first of all, is there any questions on what we're doing here first of all? Right. Well, how about I show you, how much time do we have left? They won't survive that long. I won't survive that long. Right. How about I show you some really nice examples that some of my students, I say students, some of our employees have done for us using this exact same approach. Okay? Pen drive. Yeah. So there's 18 videos, and I've done it for my first year class of how to use SketchUp from total beginner all the way up to be able to do all of this. There's 18 of those. Then there's 2 that we've done last night just for this class, and it's on purely the steel. And what we'll do here is we'll show you, how about I show you the Near Homes first of all. Near Homes is a lovely project financed by, we've got a student. Right. So we've got a project that's, let me just pull up some notes. Here we are. I'll show you the video first of all, then I'll show you the tool that we created to help people design with this system. I'll just talk over it. Yeah, it's quite. So this was paid for by Transport Scotland, and they wanted a building structure that you could reuse, take down and reuse, so no demolishing of it afterwards. But, well, you'll see in just a second. Let me take this. Made it in timber, and it's a portalized frame, so it's got moment resistance connections for all the engineers here. It's made up of glue laminated, and you can see the joints are a bit like a finger joint, how it was made, or cross laminated timber for the specialists. Now, the design had to be that the racking panels in between could be anything they want. Bare minimum, a timber frame wall, or multiple panels, and you can finish any old way that it wants. The concept behind this was, imagine you've got an old Boots the Chemist in a shopping mall and it's shut down and that unit is now empty. What they wanted to do was to take that unit and convert it into, say, offices for people that want to work from home but they may have distractions at home.
Like a remote office.
Like a remote office. And so this is the concept that they came up with. So we both worked on this together actually. At the end of this, we'll actually be building one in a few weeks' time, an 18-metre clear span, which I've not quite got there yet. So, what they wanted was, they wanted a designer, not a structural engineer, not somebody like you or I, to help them to design it and to use it, and give them a list of kit of parts without the need to involve people like you or me. Okay, that's what they wanted, so this is what we've done for them. Let's just shut that down. New Homes. It will load up, it'll just take a bit of time. So whilst that's loading up, I'll explain. We worked out we wanted the building to go either indoors or outdoors. If it was indoors, it could either be what's called a low-risk scenario. A low-risk scenario would be a shopping mall where you've just got a door into the unit. A high-risk indoor scenario would be, let me just say no to that. A high-risk scenario would be you've got a big industrial unit with a roller shutter door, and somebody may choose to open the roller shutter door from time to time. That means the air pressure is different. Okay? So, if you've got a building inside, the air pressure changes, then what you've then got is what's a horizontal load action on the building. See? There would be a load coming this way potentially, or in all directions. We wanted to know what was the thing or the bottleneck to the design? What was the criteria we had to design to? So we ran a whole raft of scenarios and we worked out the bottleneck problem is this. I'll show you. The frame, each of the frames looks like something like this. It's made up of a column and a beam. And the parts in between the column and the beam, I refer to them as knuckles. And again, structural engineers, it was a scarf joint we used. It was a joinered scarf joint in between the knuckle and the two other elements. Each of the elements are just laminated, as you saw in the previous video. And then we decided we wanted 5 sizes of system. We had the smallest one, a 210mm, that was only 7mm. Then it was a 280, that's slightly thicker, larger. Then it was a 350 by 7mm. Then it was a 420 by 7. Then it was a 420 by 9mm. And obviously all 5 of those have different strengths to each other. We also worked out, you also know that timber is very, very good in compression when it's, I don't have my props with me, but think of timber as a collection of straws, plastic straws. They bring the liquid up through the straw and what's called a capillary action. That's how a tree works, or any plants work, or most plants work, sorry. And they're the cells. Those cells act like straws. But when you grab the straws, remember when you were a child, you went to McDonald's and you picked up about 20 odd straws in your hand and you squish them like this? Yeah? You remember that, because I've done it as well. But then when you sit the straws down, hold it just loosely around like this, and you then press in the top. It's very, very stiff, isn't it? You can't compress it at all. Well, trees are the same. Timber is exactly the same. Timber, if that's my timber this way, it will compress quite easily that way. It will not compress this way very, very well at all. It'll be stiff. Because of the design of this connection, we found that the bottleneck wasn't the moment in this connection. It was actually the stiffness of the glued area here. That was the bottleneck. So all we had to design for this, and even the bending in that span, the bottleneck was always going to be the rotational stiffness or the moment resistance within this. Oh, my headset. Sorry. So, after saying all of that, if I take the tool, I'll select it, I'll go to my, not that, that's how I programmed it, this is the user menu. And if we said we wanted this to be indoors low risk, and we don't need to worry about the window loading then it's going to be the height of the bay, let's just say it's 2.4 meters internal height. The span of the bay, let's just say that it's only, say, 9 meter span. Number of bays, let's have 9 of them. And the spacing of the bays, I decided it's either 2.4 meters, because that's the size of standard OSB or plywood, or it could be 3 meters. We'll leave it at 2.4 just now. Press apply. The model has been recalculated, and it changes design, and it will then tell me the size, the system. So that was actually, it's automatically selected. It will be the 350mm by 7 lamella as the system that it's chosen. So imagine you've got your 3-dimensional model and you've got Microsoft Excel. And that you're creating variables. And if you can program Microsoft Excel, you can program BIM. Because that's all BIM is. BIM is essentially Microsoft Excel and a drawing package mushed together. Right? Trust me on this. That's exactly how it is. And this was allowing a non-engineer to specify exactly what kit of parts they needed. So in this kit of parts down here, I can see from my wall elements, you probably can't see it too well, I've got number of wall panels, 98, number of wall head bearers, 18, number of 300mm wall panels, 2, number of 200mm wall panels, 2. Then it was for the roof panels, and the data is there as well. There's a kit of parts they needed from that system. It's also identified the system as well. If I change this, and I say I wanted to go outdoors, let's first of all take off the wall panels and floor just now, so we can see it a little bit easier. Right, so there's the superstructure without all of the gubbins in the way to confuse us. Let's just say we want this to go outdoors now. That's Kenny for the second time. You want to talk to him now? Right. Go and turn that off. I'm going to say it's outdoors, not indoors now. And who's used Eurocode 1.4 for window loading so far? Who's been taught that? You've been taught Eurocode still, yeah? Good. Right, Eurocode 1.4 is your window loading. We took that code and we rewrote it for a company called Trada. Trada are your timber specialists. We rewrote it for them to simplify it for architects. So we took the mass that we published for Trada. I think you might have been involved in that as well. You weren't, but Ivor was. We took that and we then programmed it into this. Remember that Excel scenario? If you can do it in Excel, you can do it in this. And I'll show you how later on. And we just say, it's a shame you've not seen the document. But in Edinburgh, we're about 24 meters per second wind loading in about this area. South of the border, we're below that 24 meters per second. So let's just say it's in Englandshire somewhere. And then distance from the coast, let's just say that it's more than 10 kilometers. And altitude above sea level, let's make it below 30 meters above sea level. Right now, I think we're under 100 at the moment, definitely. I don't know exactly. Google Maps, Google Earth tells you exactly the altitude above sea level if you ever need to do wind load calcs. And then funneling factor, I need to ask that, but we're going to say no for this example. And peak load, there's my answer. There's my peak load for that, sorry. I'll press apply. It'll recalculate it. So it's recalculated it, and for that area, it's given me a wind loading of 0.932. And we find that's fairly conservative, a safe number. So this is published maths that we've used. Now, what it's also done, it's then changed the system, because the wind loading is much higher now, where before it was only 0.3 wind loading, now it's 0.993. So it's much higher wind loading. So it's changed the system of those 5 different sizes we had. It's now got actually the largest one there, the 240 by 9 lamella. It's chosen, so it's now chosen this one automatically to build that building. So that would then pass building warrant, pass building standards. So you can build, and before you build steel structures for industrial use or agricultural use, you can do that out of timber using this system without the need of a structural engineer. To do building warrant, you might actually need to double check it, but it will give you the kit of parts. And this is what we done, and it was quite a nice example. before I come off of this one, to show you that I wasn't joking, this is the programming that we've done. And they're just variables. Each variable's got a name. So if you can do Excel, you can do this. You can see there's maths in there. Same sort of equations you'd see in Excel. Nothing too difficult, right? But remember, for your project, you don't need to do that. This is just me showing you what you can do with what we've shown you as the entry level. For your project, all you'll need to do is to get the volumes of each material out, your concrete, steel, timber, and any other material that you might choose to use, whether it be bitumen or OSB or whatever you might choose to use. I believe it's just the superstructure, isn't it?
Substructure and superstructure. Yeah.
Perfect. Right. So we'll shut this one down now.
I think what's really interesting about that is that whatever design you do, whatever dimensions of that structure, it recalculates and gives you the volume, the change in volume, and gives you the killer parts, which is really good if you're actually building that, because you can order that
Yeah.
accuracy.
Yeah. I'll show you something a bit more simple this time. I do have one that's way more complicated, but we'll see how we go. I'll show you a very simple one now. I'm loading it up. And this is for the transforming timber. There's a video on this as well that I'll give you. So it'll only be just 2 minutes on this one, I promise. Right. We wanted to make a cutting list and purchase order list for each component of a building. This is homegrown mass timber buildings. So again, I'll pull up this. In this building, I've got what's called CLT, cross-laminated timber. I've also got NAS or GLT, glue-laminated timber, and I've also got NLT, nail-laminated timber. I'm going to assume you've all heard of these things. Nods of heads, or anyone saying I've never heard of it? Right, okay. Julio can tell you more about this stuff another time, because he's an expert in this sort of material. Right, but think of it as, I'll give you some samples. I'll make sure I've got some samples for you. But if I look at just the CLT first of all, I wanted to know, I'll explain the CLT because you need to understand that for this to make any sense to anyone. What CLT is timber that's laid in a vertical, then horizontal, then vertical fashion. So if you've got a 3 lamella system, you would put boards down, then glue on top of the boards, then put another layer but rotate it 90 degrees, then put boards down, then glue again, then put more boards down. That would be the simplest form, a 3 lamella or 3 layer system. Cross laminated timber is becoming very fashionable at the moment. You'll see it all over Europe. So we wanted to know how to make that for individual panels. I'm not going to show you how to draw a new panel because that's in one of the videos. What I will do is just know that what I'd shown you this morning of how to put data into, we only use density, and that's all you might actually need for year 1 or GWP or EE. But let me show you the output from this. If I select the whole building, press File, Generate Report, I run the report, and I'll just download that to make it easier to see. We've got a whole bunch of data. What I'll do is I'll pull up my template, not the same one that you've got, but a different template for this project. Oh, sorry. It should be in the pen drive. BIM demo, multifaceted. You can see I'm not very well prepared. I will go to here. That's the demo that I want. That's the template that I want. And select entire model, press copy. Paste it in there. Remove all my units. And I've now got a list of each of the elements. I'll just zoom in so you can see what I've got. You can see I've got cross-laminated timber, that's the CLTs. Sorry, there. Then I've got my GLTs. There's a few of them actually. And then there's 3 NLTs. I've got all the volumes and the mass for lifting purposes to crane and maneuver. You have to think about, can you maneuver what you've actually pre-designed? The type, external wall, internal wall, beams, roof cassettes, ground floor, suspended floors, whatever. Beams, we've got the blank sizes. I've also got all the material that needs to be purchased in by the company to then make this blank, to then cut that panel out from. And it's listed as the section size of section of material and the board lengths and the total linear meterage of each board size, and also how much glue would be required to glue up each of those. And it would be a simple then case of to go to the very bottom and go sum the whole lot, and that's the total amount of glue or that's the total amount of timber needed for that project. And if I happen to know my GWP or my embodied carbon properties, plonk that in, multiply it by the volume. It's as simple as that. So all you really need is the volume. You can do it in Excel afterwards. You can be a bit more fancy and do it in BIM. It's totally up to you. And then I've also got, for the project, you never saw it in the model, but in the model there was also the connections. Oh, actually it didn't come out. Oh, I didn't select it. But you've got some of the connections listed there as well for the NLT. We've got the Lignolock nails and the quantities thereof of those nails. And you'll see that also in a pre-recorded video that I've got. I think I must have spoken for more time than I've been allowed. What time is it now? Is that right? I'm conscious that I might have spoken for too long. We do have other things that we could show you, but I'm going to ask you, what would you want? I could show you the Microsoft Excel and show you how to make the macro or how to edit that macro to do something different, or you can just use it as it is. Or if you have any questions on the digital design you want to ask? Yeah, I'm not catching all the Yeah, so what we're doing just now is being recorded, hence the headset and mics. But we've also got some pre-recording as well. The pre-recorded ones there's a lot of them, so you can, it's at your leisure. What's next?